Hey there, everybody. Mr. Dickin here. Today is April 7th, 2020. Lovely 70-something degree day outside. I hope you guys all got outside on today, even though you're probably not watching this today, to enjoy the nice weather. Here is going to be kind of the start of the last thing we're going to discuss in Unit 8, and that is normal distributions. You guys have most commonly seen and heard these as bell curves. What a normal distribution says is that our center is the mean. So centered on the mean. So essentially that's saying we have a perfectly symmetrical distribution because if our center is the mean, well, the center is normally the median, isn't it? So that means our mean and the median are the exact same thing. So anytime you see normal distribution, assume the mean is in the middle. So what we're going to start seeing is that a normal distribution follows something called the empirical rule. And the empirical rule says that if you have a bell curve, so yay, bell curve, your mean is always going to be smack dab in the middle. Forgive the wonky curvy line, holy smokes. So your mean is always smack dab in the middle. And then from there, within one standard deviation of the mean, is going to be 68% of your data. So 68% is within one standard deviation. So one deviation higher, one deviation lower. Here you can see that that's marked as 34 and 34%. Well, that's just half of 68. Then the empirical rule says that within two standard deviations, so two standard deviations below or two standard deviations above the mean, we're going to have 95% of the data. So again, if I were to add all these little values together here, I would get 95%, right? We already know that the two 34s make 68. The 13.5, another 13.5, that'd be 27. So 68 plus 27, boom, 95. Lastly, within three standard deviations, you're gonna have 99.7% of all data within three standard deviations. So almost everything is within three standard deviations, assuming we have a normal graph. So that means we would have 0.3% that's kind of not within three standard deviations. Well, if it's 0.3%, that's split up for this region over here and this region over here. So if I were to split that up, that would be 0.15% on this section over here, as well as this section over here. So again, this is what's called the empirical rule. Here's kind of a bullet summary for you. If you want to pause the video here to kind of jot things down, that's not going to be a terrible idea. So the empirical rule is commonly referred to as the 68, 95, 99, 7 rule. And that's just kind of a way to remember the percentages that fall within one or two or three standard deviations of your mean or your average. These values, the 0.15, the 2.35, 13.5, so on and so on and so on, these will remain true for every single normal distribution. So as soon as you see the word normal distribution, you can automatically assume the 68, 95, 99, 7 rule applies, which means you can automatically draw in your curve labeled accordingly. The only thing that's going to be different, problem after problem, is what is our mean value. So they're going to tell us what the average is, and then they're going to specify a standard deviation. So what are we counting up or down by? That is the only thing that's going to change problem by problem, is what's highlighted right here. These numbers will not. So it is in your best interest to have this written down somewhere. Hint, hint, hint. All right, so let's see an example here, shall we? We have a normal distribution. Ding, 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 ding. That tells me I'm allowed to use the 68, 95, 99.7 rule. And yes, I realize you can't see this right now because it says normal distribution. So awesome. It says it has a mean of 50. Well, mean is going to be at the center of my graph. So we're going to be centered up at 50. And then it says my standard deviation is 11. So if the standard deviation is 11, that means we're going to count up or we're going to count down by increments of 11. All right, so if I'm going to sketch this out, I want to draw a bell curve. The middle number is going to be 50, and I count up by 11. So it'd go 50, then 61, then 72, then 83, so on and so on. Or I count down by 11. So 50 in the middle, count down by 11, so subtract 11, 39, 28, so on and so forth. So here is a very rough sketch of a bell curve. And since I know 68% is within one standard deviation, I only have to count up or down one standard deviation from my mean. Well, that would be between 39 and 61. Not too terrible, right? So now if we wanted to sketch one of these out by hand, remember, the only thing that's going to be changing each time, let me backtrack, are these numbers along the x-axis. Everything else is going to stay the same for every single example. So if we wanted to sketch one of these out, we have a normal distribution where the mean is 45, so my middle number is 45, and I count up by 5s, I count down by 5s. Well, here's a bell curve. Here's what my axis would look like. I've got 45 smack dab in the middle. One standard deviation out puts me at 50. One more puts me at 55. One more puts me at 60, so on and so forth. This would follow the exact same empirical rule where 68% of my data would lie in this region. 95% of my data would be in this region. And 99.7% of my data would be in that region there. Another example, if our mean is 52 and our standard deviation is 6.5, well, the mean, this is my middle number, 52, and standard deviation is just what am I counting up by? So I'm counting up by 6.5, or as I go to the left from the middle, I'd count down by 6.5. Really, all we're just doing is 52 plus 6.5, do that over and over and over, or 52 minus 6.5, then minus another 6.5, and so on and so forth. So here's what our bell curve should look like. Same empirical rule properties would apply from there. So now let's start putting all this to work. Here we have an example where a set of data has a mean of 50. So the mean is my middle number. Okay, so we have a mean of 50. And then my standard deviation is 8. So that means I need to count up by 8. So plus 8, or count down by 8, minus 8, minus 8. And then it's going to say find the percent of data within each interval. So first, between 42 and 58, well, that would be this region right here. Well, that's within one standard deviation of each way. If I think back to my empirical rule, well, that's 34 on one side, 34 to the, oh yeah, that's just 68. So this would be 68% of the data. Next, it says, what about greater than 34? Greater than 34. So that would be, let's see if I can, there we go. Well, that would be everything from 34 onward. Well, first off, I know that this chunk here is just 50%, right? And then this was another 34%. So now I'm at 50 plus 34, that's 84. And then I would tack on another 13.5% because remember, following the empirical rule, these percentages will never change. That puts me at 97.5% overall. Last question is less than 50%. So that's everything over here. In this highlighted, well, that's just half the data, right? So half the data, 50%. Let's see another one. We have the height of American males, approximately normally distributed with a mean of 69.5 inches. So that'd be 5'9½". Hey, that makes me feel good because I'm actually 5'9 3/4, so I'm above average. All right. Then there's a standard deviation of 2.5 inches. We want to know what percent of adults would fall between a certain range. So first thing we're going to want to do is draw ourselves a bell curve, label that in the middle, so 69.5 in the middle, and counting up by 2.5s. So 69.5 is in the middle, counting up by 2.5s. And then all I did was just kind of copy paste all of the individual percentages onto my graph because these percentages will never change. And yes, I know I should have the percent symbol. I don't. I'm sorry. I'm not really sorry. So I'm sorry for lying to you, I guess. So if I wanted to know the percent of American males between 67 and 74.5, that would be this region right here. Well, I know that, well, here's 68, right? 34 and 34. And then on top of that, an additional 13.5, add all those up, we get 81.5%. Part two says, in a group of 2,000 adult Americans, how many, ooh, we have to be careful here. It says how many, not what percent, it says how many would you expect to be taller, so greater than 72 inches. So greater than 72, that would be this chunk over here. So 13.5% plus 2.35% plus 0.15%. I'm going to have to add all those together. When I do that, I would get 16% of the people. Well, it's not asking what percent of the people. It was asking how many people. So 16% of 2,000 would be 0.16 times 2,000. We would get 320. Again, that 16% came from adding up all of those individual percents inside that region. All right, next up, the scores for the final had a mean of 150 and a standard deviation of 15. So we put 150 right here in the middle because our mean is in the middle. And then we're counting up by 15 or we're counting down by 15. These numbers here will never, ever, ever change as long as we're dealing with a normal distribution. So it says, what percentage of the students who took the test scored above a 180? So that's this chunk over here. So this is 2.35% here. And don't forget, this little tail at the very end was 0.15%. So if we added that together, come on now, we'd get 2.5%. Next, it says, if 250 students took the final exam, how many? Okay, we got to be careful here. It's not saying what percent. It's saying how many students, how many scored above 135. So above a 135, that would be this chunk right here. Well, I know this entire half is, well, half, right? So that's 50%. And then an additional 34, so that would be 84% of the students. Or I could go through and add each individual one. Regardless, I would get 84%, multiply 0.84 times the total students. And next it says, if 13.6% of the students received a B on the final, how could you describe the scores? Well, if they got a B, that means they're above average, right? So they're over in this region. Let's see, what did it say? It was 13.6. So that's roughly this region right here. So between 165 and 180. And hey, that's the range of scores. All right, last and final problem. I'm actually going to ask that you guys pause the video right here so that way you can interpret this graph. This is not an actual bell curve. So we cannot use the empirical rule. Instead, we have kind of a bar chart where we have to approximate specific percentages. So here it says from ages 25 to 34, who is, or what percent are 69 to 71? So that's, let's see, this central three columns right here. So we'd have to add those three columns together, and we have to approximate because I don't know that that's exactly 13, right? So these three columns added together, we'd get 43. Same thing, less than 70 inches. So I'd have to add all of these columns. And remember, these are all kind of guesstimated bar heights. So we'd have to add all of those together. And in doing so, we would get roughly 39%. A problem like this will show up on a worksheet and on a math Excel. Just be careful when that comes. All right, let me know if you have questions.